one last update for today, and then I'll leave you alone. Let's see. The update is on a paper by Wolf et al. That's in bioarchives, so I don't know. It'll come out somewhere at some point. A molecular pore spans the double membrane of the coronavirus replication organelle is the name of the paper, and you say, "Oh, okay. Why do I care? What's my motivation? What's in it for me?" So let's tell you a little story. So, once upon a time, there was a coronavirus. And so the coronavirus goes into the cell. Coronavirus walks into the cell, and what does it do in there? Well, we think it's going to take this thing called the endoplasmic reticulum, fill it up with proteins, stretch it out, double it back, and make these little double membraned, spheres. They're called double membrane vesicles, and the other thing that people noticed about these is that they are absolutely chock full of virus proteins and virus RNA. These are where the virus actually copies itself. So before it can make a lot of copies of itself, or kind of maybe as part of the process, it'll actually establish a little tiny factory. How cool is that? And it must take thousands of proteins to make a factory, because proteins are really little compared to the size of these things. They're massive. And so this is an area where I've worked a bit in the past. We were trying to figure out what they're for, and just did not come to any kind of reasonable conclusion. They're present whenever viruses are replicating, but you can have little ones and they're not any worse than big ones. You can have more and they're not any worse than having few of them. It just seems like, you know what? Yeah, there are different ways to copy the virus that can work in different situations. These may be a thing that is especially helpful in a particular kind of cell or a particular kind of immune response, maybe. So, yeah, I don't know. It always made sense. But the big thing was that you had this double membrane vesicle, and it had two membranes around it, and it filled up with virus RNA. And so, first of all, how on earth do you get all of the nucleotides into that thing to fill it up with virus RNA? That was something that did not make sense. And then, second of all, so great. You've just built this impenetrable fortress full of your RNA. Now, how are you going to get it out? And these are thorny problems. Anyway, what this paper does is they use electron tomography, which is like a three-dimensional electron microscopy on little tiny parts, little slices of cells. And they look in there, and lo and behold, there aren't that many, but on these little double membrane vesicles, they look like a sort of a six-pointed star sticking up like that. Or if you know a lot of biology, they kind of look like the nuclear pore, just a little bit of a different shape, but kind of that size range. And these things turn out to be the pores. This is how the virus gets its RNA out of the factory, and probably this is how the virus gets its raw materials into the factory. And the pores are made of some of my favorite proteins. They're almost certainly what's called non-structural protein 3, 4, and 6. And there might be other proteins in there. Hard to say, but non-structural protein 3. I got a soft spot for number 3. Yeah, for sure. It's a neat protein, and when I was working in San Diego with a really talented bunch of crystallographers out there, there was a lot of focus on this one, and we figured out some stuff, but it was all just like parts, little structural parts of this machine that we still had no idea what it does. This is what it does. This is the thing that it does, and a lot of that previous work now kind of clicks into place and makes sense, because now you've got this protein number 3, and all over it, it's got all of these different parts that seem to love holding on to RNA. And you say, why would this protein do that? And it's also stuck in a membrane, like it goes through the membrane way more times than it needs to. And again, you say, okay, but why why are we doing this? Why not just go through the membrane once, because then you're anchored in the membrane perfectly well. Why go through it? What do we do? 6, then 4, then 2. So why 12 times through the membrane? And some other things related to coronaviruses, look like they might go through as many as 20 times, which is also completely ridiculous. But there we go. So, this is a pretty neat paper, and it changes the way I think coronavirus people, like all of us now, are going to think about the way the virus copies itself. And now all the stuff that the virus has been doing all this time, lo and behold, it makes sense. Yeah. When something doesn't make sense in nature, it's just because you don't have enough data to be able to understand it, usually. There is something that you are missing. This is a giant something that everybody was missing, and that's really cool. So, yeah. This is a really neat piece of work, and I like it. I like it a lot. Yeah. Thanks very much. This is Ask Dr. Ben.